Hey everybody, Adam Savage here. I'm at the udvar-hazy Center, and I am in a place that the public doesn't often get to see, and I have never been. Malcolm, tell me where exactly we are.
So we're in the udvar-hazy Center, back behind the scenes. You can actually see the museum outside the windows, but This is the conservation lab. So the museum has over 60,000 artifacts. Most people know us for our large macro scale rockets and airplanes, but we have tons of other amazing stuff in the collection. And the conservation lab basically processes, documents, treats, preserves all of those artifacts.
And so some of these things are here to be preserved for going on display, but some of them are here also just to be preserved because that's part of the mission. Is that right?
Absolutely. So we're constantly collecting artifacts, bringing things into the collection. We're also finding things that have been in storage for literally decades.
Right.
And if they have deterioration or any sort of active concerns, we bring them to the lab, we stabilize them. But every single artifact that comes into the collection gets basically its sort of foundational condition report, its sort of condition status as of when it came in here. And we deal with any sort of things from just surface cleaning to active corrosion, all sorts of stuff.
And you have equipment here for determining the metallurgy, the compositional, the chemistry, and then being able to figure out ways to mitigate deterioration?
Absolutely. So if we go right over here, you'll see this is one of the instruments that we use almost on a daily basis. This is a portable XRF.
So you can look through things with this.
Well, it actually shoots an X-ray beam into surfaces, and it stimulates the electrons in the orbitals around every atom. And then when those orbitals collapse back down, it sends a signal back. So basically, we can determine the elemental composition of just about any material that comes in here.
And it's this.
And it's just this portable, very small scale thing. It's amazing. We can take it into storage. We can take it out on the museum floor and look at the paint composition on an airplane. This is a 3D digital microscope. We use this a lot as well. And these are some of the images that we've captured up here. And there's cross sections of the paint layers on the Bell X-1, first airplane to break the sound barrier. Little bits of lunar dust in some spacesuit samples.
Oh my God!
Everything that comes in, we basically, if we look at something that's been on display for a decade or so,
right?
We can always go back to the original documentation and say this has changed, or this is faded, or this is flaking.
Right.
And we can prove it.
Yeah.
And so it really prompts us to then do some sort of intervening treatment.
I would imagine that after a period of time here, you would start to have just a whole different view on the things that make up our world.
Things fall apart at a much faster rate than you ever imagined, even in museums. I mean, a lot of this is just the forces of nature and being exposed to atmospheric oxygen. And so that's what we're constantly doing is, fighting entropy.
Right.
We're trying to slow down entropy as much as possible. And
just heating and cooling can pull things apart over time.
Yeah. Atmospheric changes, the humidity changes, just all the visitors. Think about, we get about 7 million visitors a year. I mean, people exude stuff and it collects on artifacts.
It seems like you are constantly solving brand new problems in here.
We are, and that's, all the staff here, all the conservators, we come from training programs that really focus on art and archaeology.
Sure.
So that's the most amazing thing about this job here is that a lot of the stuff we didn't cover in grad school. These are new challenges. These are new materials. These are not traditional 19th century.
You're not pulling varnish off an old painting.
Exactly. A lot of what we do is so new, which makes the job incredibly fascinating because everything is a new research project. It's a new thing to really delve deep into.
And you're also documenting what you're doing for somebody in the future. So it's not just figuring out how to solve the problem, you're figuring out how to help someone solve that same problem in the future.
Yes, and a lot of what we do is sort of unrestoring things from the past. So preservation and restoration standards from the 60s and 70s are far more primitive than what we're doing today. A lot of what we do is, what kind of glue did they use in 1975 to put this thing back together? Why is it yellow and why is it cracking?
Right.
How can we safely get that off there without damaging the original artifact?
Oh, that's fascinating.
This is the Rendezvous Radar section for one of the lunar landers.
Oh, wow.
It's one of the backup testing units. Of course, all the lunar landers, were left on the moon. So we have these test components from NASA that represent this original technology. And things just, this has been in storage in a safe environment, and the paint layer starts to deteriorate. It's cracking. And our challenge now is, how do we try to save what's left? Because it's a unique type of paint used for this radar dish.
Oh, wow. And for its certain properties of reflectivity.
Yep.
And I can see some
Some oxidation on the aluminum. Absolutely. And that's when things really get challenged. When you have a substrate that's failing and the layer that's on top of it, which is failing and becoming more brittle. But over here is one of my favorite objects. So it's a component of one of my favorite objects.
60 years earlier than this one.
Yes, but representing the origins of flight. I mean, this is it's the rudder from the Wright Brothers 1909 military flyer. It's the world's first military aircraft.
I just can't believe I'm standing a few inches from it.
And it is, I mean, from a conservator standpoint, it is, I mean, things like this are so rare. To have original fabric from 1909 still intact, still on the original frame.
I'm just looking at this bent. I'm just thinking that the brothers worked on this, right? Like their hands bent these nails.
Yes.
And I see something that looks like a signature.
That is an indication of where that goes. And some of these markings, you'll see there's another control cable here. So during World War II, there was a great fear that somehow the Smithsonian was going to be attacked. And so the gems of the collection were sent out to a secret facility and put in storage in these caves. And the Wright military flyer was one of those artifacts. It was packed up, taken off to this facility, and it was still kept there.
And so that's when some of these grease pencil marks are made. So will you go to remove those, or will you leave those as part of the
We've decided to leave those because visitors can't see that from when it's on display.
Right.
It's part of its history. It's not doing any damage to the aircraft.
Yeah. And this is, it was mounted here, and the control cables went through here.
Yeah. So there was a chain, just a simple, basically very similar to a bicycle chain, wrapped around here, and then it went off to these cables and went straight up to the pilot's control. It's very simple. But yeah, you're right. These wires, and we completely took this thing apart because one of the issues with this is because it is so delicate fabric.
Yeah.
It had punctures in it. The fabric was literally starting to turn to shreds.
And just to turn to dust if you handle it, of course.
And we made this decision, all right, instead of just patching it, let's take the fabric completely off this thing, do some structural repairs on the inside, do a lining treatment, and put all the original fabric back on it.
So now I'm looking super close, I can see, but even from like 10 inches away, it wasn't clear to me. So you've got this brown linen you put on as the protective substrate.
Yeah, that's a lining fabric that goes over the entire surface.
Amazing. And then the original, so there must have at some point recently been a table where all of these fabric pieces were laid out like the Shroud of Turin.
Yes, exactly.
Okay.
Yes, yes.
You know, I know that the Wright brothers sent that letter to the Smithsonian saying, we're going to fly and we plan to fly and we want to write this letter to you for posterity. I'm curious if their early weird and wonderful knowledge that they were doing something that was super important to history is part of the reason that this still exists. You know, it's like philosophically they understood.
Oh yeah, I mean, and as they were making this stuff, they knew they were making history. I mean, that's the exact point. So, so when the Wright Model B came out, the military said, "All right, we're going to retire that airplane. It's been modified so many times, and we're going to start buying a bunch of Model Bs." And so Orville Wright said, "We're going to save that thing. We're going to donate it to the Smithsonian." It went back to Dayton. Yeah. They put it back in its original configuration, but all this fabric is original to when it was first delivered, and then it came straight to the Smithsonian, and that's why it's been preserved in such immaculate condition.
Amazing.
Come around the back here. We've got crazy things from, this is an air-to-ground missile.
Oh, really?
And one of our fellows is looking at different techniques for removing staining from the surface. So that's one of the things we do. We're always trying to cultivate the next generation of conservators and introduce them to some of these unique challenges. So we have a fellowship program, and we have students that come in and take on research projects.
And you'll give them something easy, like, here's a more modern piece, but figure out how to get this paint off in a safe way. And
yeah, bring them up to speed, and then basically let their own personal interests, guide them. Now, this is an amazing pocket watch. This just came in just recently. This is Orville Wright's pocket watch, and he carried it with him on the first and the third flight. So, as you can see, we've got it completely taken apart.
Oh my God.
The museum acquired it decades ago, and so unfortunately, it had kind of a rough life before it finally ended up in the museum. So that's why we have it apart. We're dealing with some surface corrosion issues. One of the jewels was shattered.
Are you going to restore it to working condition?
No, because
Okay.
to do that would require, doing some modification,
A real
part
over-
replacements.
Oh, okay.
Yeah. So it'll be displayed as original as possible.
Wow.
But everything's still there. The spring is still intact. All the pinions and gears are still intact.
It is so amazing that this still exists. That's
Yeah.
just incredible. Wow, look at these hands. I want to make sure there's nothing hanging off me.
Right. I know. Yeah, the screws are so small. That's one of our challenges too. Is cleaning these tiny little parts
Right.
and removing corrosion from the head of a blued steel screw without damaging the bluing. You want
Right.
to get the corrosion off without damaging that super delicate coating that's on there.
Oh my God.
So we have a huge collection of aircraft and spacecraft models, from children's models to high-end stuff that was made for the manufacturing companies and executives.
This is clearly custom.
Yeah, this is definitely a higher level custom-made model.
Amazing, beautiful work. I can't thank you enough for a tour. This is totally amazing, and I mean, everything I look at in the Smithsonian, I'm blown away and moved by the care and the love that you guys have for these objects and their histories, and how carefully you try and maintain them.
Well, thank you. I mean, we're part of the behind-the-scenes activities, but we do some amazing work back here, and it's great to finally bring it out to light and show it to people that really appreciate what goes on here.
I really appreciate the tour. Thanks.
Thank you.